Here you have one interesting question. Find I for the given reciprocal network N. Okay. So these are the two different conditions that are given for the same network. Okay. So you can once again pause and you can try the problem for yourself, which I would recommend you to do, and then if you see the solution, then it will be more clear to you. Okay. You will get more practice that way. Okay. So we will start with the solution. First we will take the first condition. Okay, so now there is a 10 volt which is giving a 2 amperes and a 5 ampere here. Okay, now what you are going to do, this 10 amperes you will switch from this position to the other position. So that means you are taking this as branch X and this as branch Y and you are exchanging. Okay, so then what will be the currents? This is 10 volt. So the response here, it should be 2 amperes. Now we know that this is a linear network. So instead of 10 volts, if you are writing as 10 times into 3, okay, by the principle of homogeneity, the response also will become 3 times. Remember, this we are able to apply because it is given that it is a reciprocal network. Reciprocal means it should be linear. Okay, and if it's a linear network, then it will satisfy the homogeneity property. So 10 into 3 will give you the response 2 into 3. So that is going to be 6 amperes. So for this network, if at branch Y we are connecting a 30 volt source, then in branch X you are going to get a 6 ampere response. So this information we got from the first figure, figure 1. Now from the second figure, if you redraw the second figure, then what you are going to get here, we have a network and here there is a 30 volt and we need to find out the current through the 4 ohm resistor, and this is the network. Now you can see here that if you consider this 4 ohms as a load value, okay, so that means if you can find out the Thevenin's or the Norton's equivalent of this entire network, okay, so this entire network, whatever I have encircled, right, then you can find out simply the current passing through the load resistance. So let us name the terminals as A and B. If you want in terms of branches, then this is branch X and this is branch Y. Okay. So now it is easier to convert into Norton's equivalent. So why that is the case? Because from this diagram, this result that we got here, this circuit is the same as this circuit as far as the Norton's equivalent is concerned. Like this part of the circuit is same. Okay. Now for this entire network, if we want to get the short circuit current, and the short circuit current is nothing but the Norton's equivalent, right? So that means we already have the value of IN, okay, because IN is equal to 6 ampere from this diagram. Now the next question is how to find the Thevenin's resistance or the Norton's resistance. Both of them are same, okay. So to find Rn or RTH. So for this network we have to find RTH. So if you redraw this network, here you have N, you have to redraw with all the independent sources turned off. So that means the 30 volt you are turning off. Is there any independent source in this network? Think about it. Will it be present? No. Why will it not be present? Because if you remember from the statement of reciprocity theorem, it consists of a passive network. That means there are no active sources, there are no independent sources. Okay. So this network is entirely consisting of only passive elements. Whatever independent source was here, we short circuited it. Right. So now we want the Thevenin's resistance seeing from this terminal. So this means that if you know the voltage here and the current here, then RTH is simply going to be V by I, because this is the equivalent, right? And now if V and I are present here, then what is RTH? Simply V by I. So now how to get V and I? From the given diagram, given question, see if this is possible. You can see here that if this is short circuited, then the voltage appearing here is 10 volt and the current is 5 amperes. This is exactly what we need, right? So if you connect a 10 volt source here, then 5 amperes is going in, right? And 2 amperes was flowing. This was from the first diagram given in question. Okay, so what are you going to get here? RTH, therefore RTH is equal to 10 divided by 5, which is 2 ohms. Okay, so that means all of the information they have given in terms of the figures, and you will have to just find out what is that, right? So therefore the final Norton's equivalent in the form of Norton's equivalent. Okay, so what you're going to get, the resistance Rn is equal to 2 ohms, the current source In is equal to 6 amperes, and what was the resistance value here? It is 4 ohms. Okay, so you can write the terminals as well. This is A and this is B, and here you have resistance 4 ohms. Okay, so by current division, you're going to get, this is the required current, I is equal to 2 divided by 2 plus 4 into 6, which is 2 amperes. Okay.